All right, what's up everybody? This is Ryan here, and today I'm going to be doing some more work on my recursive descent parser. So what I'll do is I'll give a quick recap of what we worked on last episode. I'll also talk about the things I did off camera. I did a little bit of work off camera, and then I'll talk about what we're working on today. And the good news is that the recursive descent parser is starting to take shape. I have basically all of the statements implemented, so now I just need to go through and make it so that things like binary expressions, unary expressions, logical operators are being parsed properly. And then of course I need to do a whole bunch of testing just to make sure everything's working really well. But yeah, let's get started here. That is not IntelliJ IDEA. Sorry, just let me adjust things a little bit here. There we go. What's up, Isam? So I fixed up the latency. I set it to low latency in the stream, so it should be a little bit quicker response. Okay, so last episode, or whatever we're calling this thing, I worked on, let's see, I worked on parsing statements. So I don't remember exactly where we left off with the, in the live stream. I think we finished off with while statements. So while statements are implemented. What I did off camera is I implemented if statements as well as if-else statements. So yeah, and that took a little while. And then I had something else happen which was really frustrating. Actually, yeah, it was with the if-else statement and the if statement. So just to show you what was really annoying, so normally, just to review really quickly, the way that I write the tests is, or how I suggest you write tests typically speaking. What's up, Harish? You set up the test data, so you figure out what you're going to give to the unit that needs to be tested. So that would be what we have here. You call the unit that you want to test. You figure out what the expected result is. So in this case, we have a little, this is known as an abstract syntax tree. In English, it's basically just a collection of objects in this case. In this case, we're working in sort of an object-oriented language. So it's like a collection of just these classes, essentially, which forms sort of like a tree structure, as you might be able to see here. So we do that, and then we just run some assertions. So the parser itself returns either a success result or an error result. So in the test, we basically just say, which test is it? We basically just see, is it parser result.success? And then we make sure that the result, which returns a list of base statements, which is basically what a parser does, we just make sure that the statements match our expected result. So this is basically what we want to get out of the parser. This is what we're putting into the parser. Does that match? So that's pretty straightforward if you're used to testing anyways. I just call this assert statement, slap in these two things, and then I know if the thing works, pretty much. So I tried using that same approach with parsing if statements, and I could not get the test to pass, no matter what I did. So I used the debugger to look at the output of the test, the result that was coming in. And the thing that was frustrating is I was getting a success result, but it was never matching the assertion. I had the assertion just like this before. So I spent like an hour trying to figure out what was wrong with the result, and I literally like printed out the expected result and the actual result, and compared them in Notepad, and I'm like, okay, these are exactly the same thing. To make a long story short, basically what happened was the Kotlin's contain statement, because an if statement, let's find an if statement here. Yeah, because an if statement has potentially doesn't have the second branch, the else branch, because I had this default argument in here, base statement equals void statement, for some reason that was making the test fail, even though the objects I was comparing were effectively identical. So that was really annoying. The way I had to end up solving it wasn't anything in code, it was just to rewrite the way I was making the assertions, and that ended up working, but it was just kind of irritating. Hey from Russia. Здравствуйте, товарищи. Как дела? Isam asks, are you developing a Kotlin AST parser? So I'm developing an AST parser in Kotlin for my own programming language. So the programming language itself actually looks kind of like Kotlin. It's largely based on Kotlin. Where's my spec? So this is basically what it is. Donk language is what it's called. And as you can see here, it looks quite a bit like Kotlin. Some changes, like for example, I use an instr instead of function, stuff like that. So yeah, and that's basically what I'm working on. The scanner or lexer or tokenizer, depending on which jargon you like to use, is already complete. So I'm just finishing off the parser. And then the next stage, I guess, will be the compiler, as far as I'm aware. And I'm going to end up targeting WebAssembly for this particular language, is my goal. Hello from Brazil. Bom dia. Okay. So anyways, yeah, I finished off if-else statements and got those working. So that actually finishes off the parsing for all of our base statement classes. So we've got everything we need here, unless I'm horribly mistaken. I think that's correct. So the only thing we need to finish off, other than doing a whole bunch of testing, like stress testing. What's up from Nigeria? Hello everyone, I'm from Canada, in case you're wondering. Yeah, super cool. I got people from all over the world. So what we need to finish now are expression parsing. We need to finish parsing of expressions. So I have a few of these. I have literal expressions, which are super easy. Boolean expressions, which are also super easy. What we're going to be working on is binary expressions. And I was playing around with that a little bit last night. I decided to just add in a precedence enum. And so far what we're going to do is we're going to make plus and minus low precedence, multiply and divide medium, and then high for parenthesis. But I'm not entirely sure if that's going to work out well, so we'll just see. I'm kind of doing this, making this up off the top of my head. But yeah, we've got unary expressions. We've got grouping expressions, and to be honest, I don't actually remember what those are, so I'm going to have to look that up. Variable and value expressions, I think those are already implemented. One thing I like from Kotlin, and I took from Kotlin, is you can make both values and variables. And what I'm going to do is I'm going to allow the user to create global values, but they're not going to be able to create global variables because I really hate shared mutable state. So we're just not even going to allow that in the language. And yeah, that's basically it. So we're going to work on binary expressions now, and I'm going to see, I think I already started writing a test for that, so we'll just have a quick look. I think that's in expression tests. Yeah, parse binary. Let me just make sure I set up this test correctly. So we feed in this list of tokens, that would be something that the scanner or lexer or tokenizer would, I'm just going to call it scanner for now, but understand all those words basically mean the same thing. So this is what the scanner would produce, a list of tokens which represent individual elements of the language. And then the lexer takes those tokens and creates what is effectively like an abstract syntax tree, which is basically a collection of, not a collection, but a tree structure consisting of base statements and base expressions. And this does look correct, I think. So I'm just going to rerun, or just run this test and see if it fails. It should fail. Oh, I don't think that'll work because I have compiler errors here, so never mind. Yeah, I gotta fix these compiler errors. Figure out what I was doing. So it looks like I was implementing this parse binary expression. And I think this is when I decided to add in the precedence. So let's see, parse binary. So basically, we head down to parse expression, and then if we see any of the binary operators, plus, minus, asterisk, blah, 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 then we call this parse binary function. I'm noting that we give it the index of the operator itself, so I'm just going to note this here in the comments. Starts at operator. So basically, the structure of this thing is we have an expression followed by, we'll just call it an operator, followed by another expression. That's kind of how we set this up. So this could end up being quite interesting parsing the expressions. So what I'm imagining in my head and what's going to make this interesting is we have to be able to do something like, we'll start with just a simple case, A plus B, but we have to be able to do things like A plus B plus A plus B. And that gets a little bit interesting because we have to do sort of like, I don't think backtracking is the right word, but we have to go backwards a little bit. But for the time being, we're just going to worry about covering implementing the test case itself, which is simply A plus B. And then from there, we can move on to more complicated implementations. So the first thing we do is we check the operator itself to figure out what the precedence of it is, and the operator. So we're actually just going to do this. We're going to say val operator equals tokens index. We're just going to assign that. Excuse me. Why is it complaining? Oh, because I have the val keyword. Okay. Then we're going to say operator. If it's plus or minus, then we're going to say precedence equals low. Otherwise, we're going to say precedence equals medium. And obviously, we need our else statement here. Honestly, these are the only possible values it could be, but we're just going to make it medium for now. I might end up modifying that later, but yeah. Actually, you know what? I think a more elegant way to handle that is to actually just say, yeah, let's just do that. So if it's plus or minus, it's low, and then otherwise it's medium. It's only ever going to be, wait a minute, hold on. I was just thinking that's true for arithmetic operators, but what about these other operators here? I think they'd be low. I think maybe the problem I think those are actually supposed to be logical operators. Is that what it is? Yeah, sorry. So I shouldn't even be grouping these together. That's the problem. So I'm actually just going to make a new branch here. I should have used cut, actually. Okay, let's do that. I hope I'm doing that correctly. Logical operators return. Yeah, that makes sense, I think. All right. In case you're wondering, I didn't go to school for any of this stuff, and I'm largely making this up, so expect confusion. Okay, cool. So we've got that statement there. So we know what the precedence is. We know what the operator is. Next, we need to parse the... why is it complaining? Oh, it's never used. Next, we need to parse the left and right side of the expression. So for that, that's going to be kind of interesting. The right side should be pretty easy. We basically just look at the next token on the right. The left side is going to be a lot more interesting. For the time being, like I said before, we're just going to make it work for A plus B, and then we'll worry about the more complicated situations beyond that. So the first thing we'll do is we'll parse the left side. So what we're going to do for that, I imagine, is we're going to say val... Oh, Google thought I was talking to it. Parse left equals parse expression. Okay, where is parse expression? I thought it was called parse expression. Yeah, it's called parse expression. Thank you, autocomplete. Much appreciated. That's really bizarre. I don't understand why it's not recognizing the parse expression function. Maybe because it was broken? Did I misspell it? Oh, I seem to have added a bracket where it really shouldn't be. Weird. I don't know how I managed that, but that was pretty silly. I'm like, why can't I call this function that's literally right above this other function? That doesn't make sense. Okay. Well, at least I got rid of like most of the compilation errors. Okay, so we say parse left. Now I need to give it the appropriate index, so we're not actually going to give it the current value. We need to make it walk one left, sort of. So we're going to say index. We're going to start with just index -1. Obviously, we'll have to do a lot more than that if we're parsing something more complicated. But for the time being, I think that will work. So we get the expression. It should be an identifier. Let me make sure I wrote that in here. Yeah, it should be an identifier. So we do that, and then we just check to see if that worked properly. So if parse left dot first equals error statement, then things have gone wrong. Return error, get error pair. The error would be expected expression at index -1, but got actually, no, never mind. We can just pass the error up. Parse left dot first. Okay, we can just do it like this. It's complaining because I mixed these up, which is totally my fault. Oh, stream is healthy. That's good. Okay. Okay, that should get it to stop complaining. And then, oh, right, we can use is error statement. Okay. Otherwise, we can carry on. So otherwise, we say left equals parse left dot first. And then we cast it to a base statement. Or base expression? No, we cast it to base statement because that's what that function returns, and then we grab the expression from there. No, we don't cast it that. What is it? Expression statement. That's what it is. Okay. Now we basically just do the same thing for the right side. So this one we do +1. Parse right. Okay. And so we've got our precedence, we've got our right, we've got our left, and then we say return pair. And then so we need to return a binary expression. Probably in a base statement, I would think. Yeah, okay, so we need to wrap this actually in wrap it in an expression statement, because that's just how this stuff works. We have statements, we have expressions, and we have expression statements. It's very easy to understand. That was sarcasm. Okay, so we say left, operator, right, precedence. And then we just need to give it the new index. So what we would do here is we would say index equals parse right dot second, which should be the new index, and then we would add 1 to that because reasons. And then we give it index here. All right, no more compiler errors. So let's go ahead and run the test and see if it passes. And it looks like we have an infinite loop. So we'll figure out what's going on there. Okay. Let's just figure out how far it's getting before it starts infinite looping. That's a good start. Okay, so we're not even making it to parse binary expression, looks like. Okay. It could be because I haven't really... Let's see. All right. So the first thing is we need to unpack this result here. Why is it complaining? Oh, I need to say dot first. Else we, this is parse expression. Else we just return I think we actually return that either way. Yeah, I don't think it even matters. And I don't think we do. Happy Halloween, not very good at all. It's a little far from Halloween. Last Halloween, I did a 10-hour and 50-minute coding marathon. If anyone wants to make themselves miserable, you should watch the whole thing. True story. Okay, I don't think that'll fix our issue, but I'm just going to rerun the test. Yep. Okay, so it'll be seeing an identifier. I think probably what's happening is it's seeing the identifier and it doesn't know what to do with it. So I need to think of how to handle that. And that's going to be interesting. You know what we're going to do? We're going to actually simplify this a little bit. We're going to say 1 plus 1. We're going to do that. And let's just make sure this is a literal number. So let's start by doing that. Okay, we still have our infinite loop. So it should be creating an expression statement here. Let's just make sure it's doing that. Hey, what's up, Baekhyun? I think that's how I pronounce your name. Okay, it's almost like it's looping in. The only place that actually has an infinite loop is or it has a loop rather, is the parse block. I don't know why that would be getting called. Okay, so parse declaration is getting called. Parse statement is getting called. Parse expression is getting called. It gets a literal number. And it should return that. Okay. Then we get to parse declaration. Parse statement. Okay, so the index isn't being increased, so that's why it's endlessly looping. So when we created this literal, we need to increment the index. Okay. Okay. No, that's not what we need to do. We do index plus plus. Okay, let's do that. What's up, bro? Okay, so our test is passing now. So that's fun. I'm just going to rerun the other tests because I'm a little bit skeptical. I think that might have actually broken something else. So let's just rerun the other test suites to make sure it's working. What's up, Breeze1? Yep, that's what I thought. Okay. I thought so. All right, just 1 second here. It looks like I am more than a tech lead. Oh, that guy's my favorite human being on this planet. He's just such a genuine and honest person. Okay, well, this is frustrating. So, parse statement tests. Oh wait, no, that's actually fine. No, it's not fine. Parse declaration tests. Let's start with this. That one should be breaking now. Yeah, that one's broken. Okay, so let's figure out why this one's suddenly breaking. We're basically playing like test whack-a-mole here. Okay, so I bet that one would pass. Hold on a minute. Parse expression, if statement. Where's my if statement? Okay, it's complaining because when it parses the condition, it needs to be incremented by 1. No, it doesn't need to be incremented. That's weird. Okay. I'm coming to understand that the biggest problem in oh, it's breaking here. Match types. So this is the else block. So the reason why this one is breaking, okay, so what we need to do here, this is a situation where I need to add in a check here. So what we're going to do is we're going to throw an and brackets, and we're going to say, excuse me, index plus 1 less than or equal to tokens dot size. That, I think that'll fix that particular issue. Nope. Same problem. Well, now I'm slightly confused. If index plus 1 is less than or equal to What's up, Patrick? Oh, that fixed it. Okay, so that fixes that little issue. I don't think the change I made in the expression parsing thing actually caused this particular issue. I think that was probably a separate thing. I just forgot to rerun all those tests last night. Let me just run the other ones. Okay, those are working. Expression tests, I just ran these, so I know they're working. But I'm going to run them again. Oh wait, no, the expression test shouldn't be working. That one's still infinite looping. This one, yeah, those are working. Okay, we're good to go for now. So what I want to do is let's go back to parse expression, if I can find it. Okay, parse expression. So I have this rule up at the top of the class here, which says caller increments by 1, not callee. The reason why I have that little rule there is how this thing effectively works is you have some kind of source code here, and it's presented in a list of tokens, and I increment this index basically to keep looking as, imagine that being the eyeball of the parser. Now I have to be very careful how I control this eyeball, because if I do it wrong, I end up looking at the wrong token and then everything breaks. So my general rule here is that a function which calls a sub-function, a helper function, will move the eyeball over. The callee itself will only move the eyeball as far as it needs to parse its own little statement. Now, the difficulty here is that in parse expression, I kind of need to, in the case of when we simply parse a literal, I kind of need to move it over myself, it would seem. So I think we're going to do that. This should be index here. So we're going to try that and see if that gets rid of our infinite loop. And I was just thinking to myself, if we do it there, why wouldn't we do it here as well? So it's tricky, because parse expression is both something which will call other functions. What's up, Nikhil? But it's also something that's potentially going to get called. So it's kind of in this annoying zone where it's both a caller and a callee. But let's just deal with the problem at hand. I'm going to run the test now. And that one's passing now. I'm just curious now if I run those other tests. I don't think they'll break, but let's just double check. Statements. Okay, it does break one of these if we do that. I was worried about that. So I've got to think of how to solve this problem both for the unit itself and all the other units that are depending on it, which is tricky. I think possibly what I need to do is I need to pick one or the other. I either need parse expression to increment the index, or I need, or it never does. And then I need to adjust the rest of the code accordingly. I'm tempted to say that parse declaration, parse statement, and parse expression should increment their indexes. I think that's the most consistent way I can do this. So we're going to try that, and we'll see how that kind of goes. Let's try that. Okay. Yeah, we'll give that a shot. Now that's going to break a bunch of other stuff. So now I'm once again going to have to rerun the other tests and just fix all of the errors, which is okay. Well, that actually surprises me. Parser declaration, parse statement test. Something's got to break here, I'm sure of it. Yep, parse return statement broke. So let's go to parse return statement. It calls parse expression, so we're just going to remove the +1 from here. Okay, and then we're going to rerun that. Okay, that, I was actually expecting to have to spend a number of minutes fixing that, but that didn't take long at all. And then let's look at parser expression tests again. Cool. Okay, we're making progress here. Okay. All right, it's time to write another test. So we'll say parse. This one will be called parse simple binary. Let's say actually parse. Let's be a little bit more descriptive. Parse literal binary, because we're giving it literals here. We're going to copy paste that whole thing. This one will be parse identifier binary, and this would be A plus B. This will be an identifier. Yeah. What's up, Cease? Oh, my computer's suddenly slowing. I wonder if Windows Defender or something is going on here. Okay, cool. Okay, so now I'm going to run this test. I would be quite surprised if it passed. Probably it'll be an infinite loop. Yep, infinite loop. Okay. That's pretty much what I expected. Okay, so now we have identifier. I don't have a base expression for identifiers. So I'm just trying to think, how do I actually how do I do this? So I've already implemented parsing for example, val a string equals blah. We can parse that. We can do var b equals double 2. What I don't have is I don't really have an expression for just the identifier. So for example, like a equals 2 semicolon. So there's kind of two ways I could deal with this. One way is I could wrap it in a literal expression, but I don't really like that, because how do I know when I'm dealing with a string literal and a identifier? Can I do that in the literal expression? Okay, I can just give it a donk token. Okay, I probably will just wrap it up in a literal then. Let's try that. So this might actually be a pretty easy fix here. So token type dot literal, no, not literal, sorry, identifier. Wrap it in a literal expression. Okay, let's try that. Okay, that fixed up that one. Okay, so we've covered a plus b, we've covered like 1 plus 1. Now we need to deal with this thing here, which is going to be interesting. So parsing the, I think that might be a grouping. Let me just double check that actually. Just give me one moment, folks. Okay, so using parentheses to group expressions is, so yeah, that would be a grouping. So this might actually be a little bit easier than I anticipated. So what we need to do is, I guess we just need to look for a bracket and as an expression, we look for a either a left or a right bracket. I should say parenthesis. And then we just look for the next one. So this might not actually be as difficult as I thought. But what I'm going to do is I'm actually going to make a new test, which has nothing to do with our binary expression. And we're going to cover groupings with a different test. But yeah, and then eventually we will write a test with the binary expression and the groupings, but that's one, if you don't learn anything else today, folks, when you're doing like test-driven development on something as challenging as this, like writing a parser that requires just very, very exact code, try and test the smallest, simplest thing first and then gradually build up from there. I think that's a really, just a really good general rule. We're going to, again, just copy and paste this whole thing because I don't feel like typing it out. So this is going to be parse grouping. And here we're going to do, I think we'll do 1 plus 1. We're just going to add parentheses to it. So this will obviously be left paren. This will be right paren. And then we need to, so this will be a grouping. Grouping expression. Get rid of precedence. So what does a grouping look like? Just an expression. That doesn't make a lot of sense to me. One second. How could it be just an expression? Oh, this is going to get interesting. Okay, interesting. I guess, okay, definitely going to have some recursion going on here. So again, going by what I literally just said moments ago, we're actually going to start with a simpler test, which is just going to be a grouping of 1, because things are going to get more complicated. the reason why is I just look and see here. So a grouping has only one expression. So to handle parenthesis 1 plus 1 close parenthesis, to handle that, this would be a binary expression. But I just want to start with the simpler case, which would be a literal number. All right, so I'm going to run this test and it's going to fail. Yep, it's not actually failing, it's just infinite looping. All right, and now we go into here. So now we're looking for token type right paren or left paren. Possibly also right paren. Let's start with left paren. Oh. Val parse group equals parse grouping expression index tokens. Pretty much the same stuff. Okay. Then we're going to create that function. I can't spell apparently. Okay. So that's what we're doing there. Okay, so we pass in the current index. Okay, so starts on Is that correct? Is that correct English? Parenthesis? Let's just say parent. Okay. So what we do, we get the parenthesis, then I think we just call parse expression next. Do I just call parse expression right after? I'm just trying to think, what are we actually allowed to put in the grouping? I think any kind of expression. So I think that would mean we can actually just call I think I know what it is. So we probably need a loop because we could have lots of things in the expression. We loop until we hit the other parenthesis. Hello from Canada, Mr. from Indonesia, or Mrs. Statistically speaking, probably Mr. But yeah, welcome. So why I'm waiting here is I'm just trying to think if I should prematurely basically I think what I'm going to do is we're going to have two different kinds of parse grouping expression. We're going to have one that travels backwards and we're going to have one that travels forwards. At first I thought maybe I could stick them in the same function, but then I was kind of thinking I need to change how the loop progresses, and I'm not actually sure if I should. Yeah, I think I'm going to do it differently depending on if we start with the right parenthesis, parent, let's call it that. The right parent or the left parent. So let's just start with left and we'll deal with that specifically. So we need a loop. So we'll say var index equals current. We're going to have it's either going to be a single expression, a literal expression, a binary expression, a unary expression, the reason why I'm pausing, I'm just wondering how much premature optimization I should do here. Let's just say while tokens index does not equal, oops, that should be type. Not equal token type dot right parent. Okay, while it doesn't equal that, we loop, and I should probably have like a, in case we exit the size of the array, and index is less than or equal to tokens, I should say less than tokens.size. Then we say let's say starts after paren. Let's do that. Parse group. So we're going to give it index +1. Okay. Then we need our when statement. And then we're going to do, the first one will be just a literal expression. So this would be, so when it's a literal expression, oh, this is interesting. This is the, so this one's going to be a little bit trickier than the other stuff. So we have to be able to parse groupings where it's like bracket, bracket, A, bracket, plus A, plus B, plus, would I even allow that? Oh, this is tricky. This is actually a trickier problem than I really anticipated. So for those who are actually listening or watching, the 4 people or whatever it is, I need to figure out how I'm going to let my parser kind of deal with these sorts of statements. I can deal with binary expressions, but how would I deal with like a triple here? A plus B plus C. And then obviously it's got another. it's almost like I need that to be its own binary expression, and then a plus that. So binary, yeah, hopefully you kind of understand what I mean. Oh, this is going to be fun. Well, again, in keeping with my convention, let's just solve the test at hand, and then hopefully we'll see what happens after that. So for the time being, our test says we're just trying to create a grouping of one literal number. So we're just going to say literal expression. If it's that, we're going to say return pair. Do I want to do it like that? I think what I want to do is if tokens index plus 1 match types, this is just a little helper function I wrote. If that, then we do want to just return the literal expression. So in that case, we would say if blah return pair expression statement literal expression I feel like I'm kind of doing this wrong. I feel like here I should call parse expression. I think I should just call return parse expression index tokens, and then we return index plus 1. Why can't I do that? I guess I just return parse expression. This is where the whole recursive descent thing comes into play. Index tokens. Okay, I think I do that. So if match types return blah, otherwise I think we just increment index. This shouldn't be literal expression, so this would be of type I feel like I'm doing this all wrong. We skip over the left parenthesis. We call parse expression until we've exhausted the until we've hit the right parenthesis. Oh, this is a fun one. This is a nice puzzle. I'm just trying, I feel like I need like a friggin', I need to do one of two things, I feel like at this point. I need to say that that doesn't feel right though. I was going to say I need to say that the user can only have up to a binary expression in a grouping, but that doesn't feel right. And I feel like there should be a way to how can I explain it? I feel like we need to have nested binary expressions to represent more like this situation here. I feel like that's how that probably gets handled, but my brain is just having trouble thinking of how to write that in code, and I feel like it's probably simpler than I feel like I need to just keep calling I think it's just a recursion problem. Okay, for the time being, let's just keep it simple. So if match types, parse expression, let's try oh, my brain. Okay. Let's just do parse expression for a moment here. We're going to say, so we've got to the parenthesis, parent. We begin parsing a new expression. We say return parse expression. But I need to return the appropriate index, which should be fine. So we say okay, that stays there. Val okay. If match types tokens index parse expression +1 dot, oh, that should be parse expression dot second, and then if that is token type dot right paren, then we just return parse expr. Okay. Now I'm questioning if I actually need a loop in here. Okay. But instead got okay, we're just going to do that for now. I don't think it's going to work, but let's just run a test. Yeah, okay. Okay, assertion failed. Well, we're making some progress here. Okay, so let's see. Okay, it was actually a successful result. It wasn't an error, but it's different from what we received. So we received an expression statement. Okay, so there was no grouping. Okay, I think I know how to fix that one pretty quickly, actually. So we return a grouping expression. Which consists of just give me one moment here. So we need to say if parse expression dot first is or sorry, not does not equal error statement. Okay, if it's an error statement, just return get error pair. Let's do it that way. Else, we return our grouping expression. This is the kind of code you just know you're going to come back and look at when you're more rested and just be like, what the hell was I doing? Okay, grouping expression. So we say dot first. Then we need to cast this thing. Then we need to return this as a pair. And what do we return? Parse expression.second, I guess. Okay. Okay. Now, why is it complaining? Base statement. Oh, because this needs to get wrapped. Oh, this is so frustrating. Okay, so this is going to be an expression statement. Okay, cool. So let's see if all that crap I just did makes the test pass. It did. Okay, so we have implemented groupings which consist of a single character. Progress is progress. All right, so what I'm going to do is I'm going to need more time to mentally sort out groupings, because I'm going to have to break out the whiteboard and figure it out from there. So we're going to switch gears. I'm going to work on Unary expressions. I think I can probably finish those off pretty quickly, and then I'll probably call it a day for today. But before we get into some more complicated water, we'll do that. Now we'll do Unary expressions. So now we're going to do not, we'll say not true. I'm hoping Unary expressions will be a little bit easier to deal with. So this would be a Unary. This would be a literal. How do Unary? So we have an operator and we have a base expression. So this would be not. Really? What did I call? Oh, I think I called it like exclaim. Yeah. So that is the operator, and then we have a base expression. So that would be a Boolean expression. Which consists of this thing here, and I just noticed this needs to be true. Okay. Now, why is it complaining? Because this is not actually a literal expression. Okay, cool. All right, that is our test setup for the Unary expression. Interesting that we're getting an array index out of bounds exception. That's weird. Why would it do that? Oh, because that's left paren. That's why. Okay, that makes sense now. And see, this is why we run tests before we write any of the implementation. It helps you to figure out if your test is itself well formed. All right, so we're getting an infinite loop, which is expected. So we go into parse expression again. And this time we do token type exclaim. Parse Unary expression. And we'll go ahead and rate that. I'm actually going to probably just copy parse binary expression because it's probably going to be pretty similar, just smaller. So we're not going to have left. I don't think we care about precedence for Unary. Let me just double check on that. What are our actual Unary operators? So we have not true, not some kind of expression. We're not going to worry about that though. Is that the only Unary operator? Let me just double check on that. I think in donk language we only have one unary operator. I can't, if there's another one or others, I can't think of them. Or no, token type is what I want. Exclaim. Okay, yeah, well, for the time being, we're just going to implement it for exclaim. So we won't need precedence, in other words. We've got the operator, we've got write, which is base expression. That looks fine. We can skip all that. We don't care about the left side. So we just say parse write. We make the, actually no, I was a little overzealous there. We do say operator equals tokens index. Yeah. And then we parse index plus 1. This one returns a unary. Okay. And that test is probably going to pass now. Boom. Okay, well, I think I'm going to call it a day. I'm definitely going to do more work off camera, but the truth is that I need to grab my whiteboard and just kind of mentally figure out how I'm going to deal with nested groupings and stuff like that, because I didn't really think about that. Plus C, B plus A plus C. I didn't really think about this. That's basically why. I feel like there should be a way to solve this pretty easily with recursion by just recursively calling parse expression, but my brain's just not really formulating how to do that. And the way my mind works, if I can't actually formulate a problem, it's very hard for me to make progress with it. So that's basically it. But we did some good work today. We got unary expressions working. We got most of our binary expressions working. The ones that aren't working are ones which use groupings. So I think that's fair. Let me just make sure that those are still running or passing the tests. Yeah, everything's still passing tests. So, yep, this has been Ryan rambling away for another episode of Let's Build a Compiler. Yeah, I'll probably do this again tomorrow. Also important, I will be doing my live stream Q&A on Sunday, which is 2 days from now. So